Hey everyone, welcome to Code Harmony. Today we are going to solve LeetCode problem ID 3160. Find the number of distinct colors among the balls. This question is based out of hash table. Let's have a look on the problem statement. We are given an integer limit and a 2D array queries of size n cross 2. These two are our input, and they are also saying there are limit plus 1 balls with a distinct label from 0 to limit. Limit integer is given to us. They are saying that we have limit plus 1 balls. It means 0 to limit indices. Initially all the balls are uncolored. There is no color of the ball. For every queries that is in the form of x comma y, you mark ball x with color y, and after each query you need to find the number of distinct color. Okay, so let's directly have a look on the example. They are saying that two values are given to us. First one is limit and second one is queries array. What does limit mean? Limit means that we have balls from 0 to limit. From 0 to 4. 0, 1, 2, 3, 4. It means limit plus 1 number of balls. And what about this queries array? The queries array are having queries in the form of x comma y. Only two values are there. Here x will signify the ball ID and y is the color with which I'm going to color the ball. Okay, so if I just clear these stuff and if we have a look on the queries, first query is 1 comma 4. It means you have to color ball number 1 with the color 4. Ball number 1 will be colored with color 4. Ball second will be colored with 5. Mark the ball number 1 with color 3. Initially the color was 4. Now they have updated the color. It means the color is getting overridden with 3. Now ball number 3 we have to make a color of 4. Ball number 3 will be colored with 4. And this is something we have to do. And along with this, they are also saying for every query, whatever query we are processing, after each query, we just have to return the number of distinct color. After first query, we were having only one color. Let me show you again. First query is something, ball number 1 will be colored with 4. Okay, there is only one color. These uncolored ball are not a part of color. Only one color is there. Yes. At 2, 5, 2 will be marked as 5. Now we have two distinct color, 4 and 5. Two distinct color. One will be marked as 3, 3. Now how many colors do we have? We have two colors. The 4 is gone and 3 has come at the ball number 1. So we have two number of colors. And what about 3 and 4? 3 is marked as 4 color. So we have three different colors, 3, 5 and 4. So this array we have to return from this problem. 1, 2, 2, 3. So this is expected return from our function, and these two values are given to us. Let's also have a look on the return part. Return the array of result of size n is the number of queries n cross 2, where result I denotes the number of distinct color after ith query. Okay, this is something we have to do. Now how we are going to solve this problem? After every ith query, we need to return the number of distinct color. So if we want to get the colors, why not we have to capture those colors somewhere. Capture how many colors are there and what are the balls or maybe number of balls the color is going to have. Okay, but we are only concerned about the number of colors. So if I just take a map which is going to give me, in which I'm going to have an integer which is my color, and apart from that integer what I should have? List of balls. No, list of balls is not required. Even if I just take a integer value is more than sufficient, because we can be happy with the number of balls with the corresponding color, right? And why the number of balls? Because there is a possibility that, let's say, the ball number 0 has been marked with color 7, ball number 4 has been marked with color 7, and then ball number 4 has been marked with color 8. Now 7 is also there, but if the ball number 0 has been marked with color 9, then color number 7 is gone. It means we should know how many balls currently have that specific color. So for that, number of balls with a specific color is definitely required. It means that if the number of balls is becoming 0, right? If none of the ball is currently having that color, initially one ball was having that color, but now that ball is gone. So we have to remove that entry as well, remove that color from this map as well. Okay, so that map we can take where it is going to take integer, which is our ball, not the ball, color. So using this map we'll be able to get some value. So let's say initially in this table, first ball is marked with color 4. Color 4 has a count of 1. There is one ball with color 4. Now after second query, color number 5 is having one ball. Got it? Now after third query, color number 3 is having one ball. But if you try to analyze that this 4 entry we should remove somehow, right? Because this 4 was colored to 1 and this 3 was also colored to 1. So we have to override this 4 with the 3 value. It means if we just get an answer to at this level, we are seeing that there are 3 different colors, but actually there is only two different color, which is 3 and 5. This 4 is overridden by 3. Okay, so it means that only this map is not sufficient. Map with the value, color and the number of balls with the same color, right? So what we should do in this case, when we were coming at 3, one ball was marked as 3. One ball is marked as 3. Before we marking a new color, we should see whether there is any existing color or not. Okay, so this is something we need to get before giving an entry in this map. So we will see whether this ball number 1 is already colored or not. So how do we get to know? From this map I cannot get that, because this map is going to have a key as a color ID, but I am now dealing with the ball ID. So ball ID with a specific color. So for that, if I just take another array, because balls are going to be from 0 to n-1, if I just take another array, initially the whole array is initialized with 0. We can assume that 0 means no color. So when the first query will come, 4 color is assigned to ball number 1. So the color number 4 is assigned to ball number 1. Color number 5 is assigned to ball number 2. 5 is assigned to ball number 2. And now when I'm trying to assign color number 3 to ball number 1, I will see that okay, this ball is already colored. Now I'm able to get that value, whether the ball is already colored or not, in the constant time. So this is something was required for us. Now when I will be coming to third query, I will see in this array that okay, whether this ball number 1 is already colored or not. Ball number 1 is already colored with 4. It means just remove that color and add a new color. If we have to remove that color, it means we have to remove the entry from the other map as well. Color number 4 has been removed from one ball. It means this value will be reduced -1. So it's already 1 minus 1 is 0. So there are 0 balls now with 4 color. If there are 0 balls, then remove the whole entry as well. Okay, and now update it with 3. Now after this step, I will just see how many different colors I am having, and that I can get to know using this map, right? This map is going to give me size of 2, and that is my answer, that after this step we are having 2 colors, right? So what we have utilized so far is we have taken a map where it is taking an integer, which is color, and integer, which is the count of number of balls with that color. and now there is an array of size equal to the limit plus 1. That array I can utilize to capture the current color of that ball. Okay, and what is going to be the time complexity in this case? Time complexity will be, we are iterating over the queries, which is order of n number of queries we are having. And what about the size of what about the space in this case? See, time complexity is order of n. What about the space complexity? For the space complexity, we have to look on the constraints. Okay, this n is the number of queries. Number of queries, if you just have a look, it is going till 10 to the power 5. This queries dot length is equal to 2, and query first value is going till limit. But if I just have a look on the size of limit size is going till 10 to the power 9, and this is only 10 to the power 5, right? 10 to the power 5 is way larger than 10 to the power 9 is larger than 10 to the power 5. If our work is able to get done in 10 to the power 5, then there is no need to take the whole array. And why I am telling that? Because here at this moment we have taken an array of size which is equal to 10 to the power 9. We are considering this array as a hash to capture what is the current color of any ball. Let me show you the core of this approach. See, number of queries are n in number. Let's say the limit is of size m. So the space complexity will be m plus n. What do you understand with this? M is going to be the size of limit array, that is going 10 to the power 9, and this is going 10 to the power 5. So around 10 to the power 9 the space complexity is going. So let me tell you, this solution is going to give us memory limit exceeded. The memory limit will exceed for this solution just because of this array. Let me show you the code of this approach. If you just have a look on the code, here what I have done is I have taken a map. This map is going to store the color and the count of balls, right? And then another array which is equal to the limit plus 1. Because the limit is the number of balls. Number of ball will be marked from 0 to limit. It means limit plus 1. So I have just taken an array of size this, and this is just some variables. Answer is to store my answer after every query. Now this is my query. After each query, I'm going to store the size of the color map, right? Now current query is ball and color. We are getting a ball and getting a color. First of all, we need to see whether this ball is already colored or not. If this ball is already colored, we have to do something. Otherwise, just color this ball and increment the counter in the map. That's all. But if the ball is already colored, then capture the old color, remove the old color count from the map, and see if after removing the old color count, if the number of balls with the old color is getting equal to 0, then we have to remove that entry from the map, right? This is something I am doing. So here in this case, I'm iterating over every query. Iterating over every query means order of n size. Order of n size is for the time. Time complexity is order of n, but here in this case, this array is going till 10 to the power 9. But if I just take a map instead of this array, then what is the size of this array? Currently the size is already 10 to the power 9 because it's already fixed. But if I just take a map instead of this array, then according number of queries are going till 10 to the power 5. It means we can have a maximum of 10 to the power 5 entries in the map. But in this case, we have initialized an array of size 10 to the power 9. So if I just submit it, I'm going to get memory limit exceeded because of this array. Let me try submitting it. The code is working fine on sample test cases, but if I submit, I'm getting memory limit exceeded because of this array. So this array need to be modified to this map. Okay. So in our approach, what we did is we just captured one map for color and count of balls. And for the second thing, I can also take a map. If I just take a map, let me call it ball color, bold color map. So this will be commented, and this is bold color. First of all, I'm getting the color. This condition need to be modified. Whether bold color contains key. What is the key? Bold. If the key is already present, the bold is already colored. Then find the old color. How do I find the old color? Bold color dot get bold. This is my old color. Now map dot put old color -1. This is working fine, and this is also fine because it's already mapped. One more thing, for the old color, the entry is going to be deleted from the bold color as well. Now this bold is not at all colored. We have to just to give it a fresh color. What about the fresh color? Then map the bold color dot put bold with a new color. Bold with a new color, and this color, the frequency will be increased by 1. Now the space complexity will be improved from 10⁻⁹ to 10⁻⁵. In this case, bold color will remove bold from it. Now we have improved the space complexity from 10⁻⁹ to 10⁻⁵ by using a hash map instead of array. Let me submit it again. This time it is getting submitted successfully. I hope you understood the approach. Thank you guys. Bye bye.